Okay, so here's a little addendum to exercise 44, where we were doing a plot slope field. And so you can do that fairly easily in SageMath cell, so I can see the slope field. So what I did was I went to Google and typed in SageMath slope field. I find that tends to work quite well to just say SageMath and then whatever I need. I went to this very first link and scrolled down a bit, not very far. The scroll is over here, so I didn't come down too far, and I find this example. So what I did was I can copy this. Again, let me make this just a little bit bigger. Not sure why I don't have the bottom part here to scroll. Maybe this things are just a little too big. I don't know. We can see it, but I can highlight that and do a Control C, come over here and do a Control V and paste that in. So I've got these variables now. Typically I don't just put a space, I put a comma. I don't usually write the XY on this side with the equals. You can get away with just that, and that's fine. Then what do? They notice here it's the slope. They do a plot slope field. Well, the first thing they have is what's the slope field of. So I'm going to call it F prime or FP equals, and it was -1 over x squared, like that. So there's my F prime that I want, and now I'm gonna highlight this thing. It's got a bunch of things that I don't really need, so again, Control C. I'll just edit them out when I'm in here. Control V. So there's the command, plot slope field. All this stuff is simply F prime, so I'll put FP. And then I think ours went from 0 to 7, and Y went from -4 to 4, I think. And so, I just tell it plot the slope field, FP, and from X goes from 0 to 7. What do I want the window to look like? And I do that. Now, I'm not sure if we're going to see anything. So let's see, just saying plot the slope field. Yeah, it showed it. Okay. Now, the reason it showed it, I think, is because it's the last thing we did. So just for the heck of it, say you had to do one other thing, like, I don't know, F prime prime. I took the derivative, and that would bring down the -2, so I would end up with 2 over x cubed. Suppose I did that, just for whatever reason I needed to do that. Let's see what happens when I evaluate. Yeah, notice, see, nothing shows up, and it's possible sometimes you could have done this and nothing would have shown up. So what do? Well, I make a plot. Maybe I'll call it P. P equals, and actually this equals, it's an assignment. It's not really an equal sign as to these two sides are equal. It's saying declare something called P and assign this thing to it, and more like a function. And now I'm just going to say show P, and that I know is going to work. Well, I mean, as long as everything else works. And you see there is my slope field, and Again, we were at 1, 3. Now, you know, you can do even more with this. You could plot that point 1, 3 in there if you wanted to. I'm not going to go into that right now. Well, I don't know. It wouldn't hurt. Maybe I could do that. Let me try it just on the fly. So I could go in here and say LP for a list plot is equal to list, and I'd have to go look this stuff up if I didn't know it. But list plot, and I am going to try just doing the point 1, 3 and close that. And now, of course, it's not going to show up, but what I can do is plot both plots together by saying P plus LP here in the show. You could even assign it to yet another name. Let's see what happens. Might give me an error. No error. And there it is at 1, 3. Now it's kind of a small dot. I can make it bigger by, you know, looking some things up. And how would I look it up? Well, I would go to SageMath and I would say, okay, list plot, and right there, and 2D plotting. Okay, I would go to that, wait for it to load, and, you know, kind of look down. Oh, list plot. So I'll click on that, and here's a, you know, data, plot join, aspect ratio, all these different things. Okay, so I see that. Oh, here they changed the color. All right, so color is red, so I can see examples of stuff doing that. Here they said plot joined and color purple. Great movie, The Color Purple. I'm not sure what they're doing there. You know, I'm just looking to see if they do anything where they make the dots bigger. So all these are just different list plots that they show examples of. All the dots look the same size. I don't see anything bigger, but it's still at list plot stuff. Different types of axes, I guess. You know, so I keep going down. Multi-graph. Okay, so it looks like I'm out of the list plot. You know, so I didn't see anything there, but I might come up here and see if there's anything else. Examples. No, I don't see anything on the size of this thing. Now, quick search, I don't know if that's searching this page or what, but, you know, I could definitely go here and where's find in this page, and I don't know, size. Okay, there's figure size. Okay, great. Maybe I could go here and do dot size. How about that? Oh, pink, no good. So I'll go back, size. You know, 1 of 30 matches, that's not too bad. I can just go down, figure size, figure size, figure size. Yeah, all that stuff's figure size. Point size, look at that. So I could go back here, and that says 30. I could just try that, comma, point size. So again, Control C. I go in here, list plot, comma, Control V there with the point size 30. Evaluate, and it's bigger. It didn't take me too long. Oh, that's weird. Oh, I don't know if it did that before. Okay, so when it plotted this, it didn't plot it as the coordinates I wanted. I got lucky with the 1, 3. So this part isn't quite right. Okay, it's saying, oh, x is 0, y is 1, x is 1, y is 3. So, you know, I'd have to look a little more at how I fix that. You know, I don't know, possibly putting it in square brackets. That might just give me an error. Nope. And it fixed it. You know, I've used Sage a bit, so I had an idea of what might work. But there we go. So I've plotted the slope field. That took, I needed to tell it, and really I only needed x because y didn't show up anywhere. This y is fine. Let's check that to be sure. Okay, you can always experiment. We hit evaluate. Oh no, it was not happy. So because I had that y there, I need it up here. And so x comma y, and then it's happy again. And so I had to declare that x and y were symbolic things. I had to tell you what my derivative was that I wanted the slope field for. Now I could have just put it right in here. I could have put this minus 1 over x squared right there. But I think it's a little cleaner and easier to read what's going on if you do it separately. But I just told it what I wanted for a slope field and what my x and y bounds were. Not that bad. And here, if I wanted to use a point, I did my list plot, and I found out I had to put the point into square brackets, otherwise SageMath thought I meant something else. I could change the point size. I saw I could change the color. I don't really feel like doing that. And you know, and if you look around and explore, you may find you could get some other things with the plot slope field. You know, here's the plotting fields. If I look down here, this is just some different examples. Ooh, a vector field. It's got arrows. We don't need that at this point. Ooh, nice colors. Okay. Ooh, that's really fancy. I'm just looking to see if they ever plot a solution on there. I don't see a solution plotted on there. You could make a separate plot, you know, for the solution to go on there and add it just like I added the point. Well, I don't know. Again, hey, I suppose you could always stop watching the video. Let's look at how to add a solution. Now we could get really automated here in that, you know, f prime is the minus 1 over x squared. Remember that we know how to find f. F is just f prime dot integral with respect to x, and it did not add a c value. Now, but this is where we have to be careful, right? So we've got this integral, and we could show that. Show f to make sure we're doing it right. So 1 over x, great. Okay, so our antiderivative is just 1 over x. But we need this thing to go through, was it 1 over x minus 1 over x? Yeah, okay. As I say, don't wreck a good story with facts. We're doing this one. And we have 1 over x, and that's our antiderivative, but we need it to go through 1, 3. And so remember that the actual answer should be plus a constant c. Now, if I just call that c, I need to add it up here. So put space there. Okay, so now evaluate and show this. And there, I put the c first, but that's okay. So there's f. But I also know, and I can just solve it here. So I'll say maybe an uppercase C is equal to, or I could have called it C1 or something like that, or C known or whatever, but this is the solution when I solve. So I want to solve an equation. So what's the equation? Well, it's F is equal to, I think we were told 3, right? F of 1 is 3. And I want to solve this for C. Okay, now this isn't going to work because, well, it's got the X in there and so forth. I need to tell this that F needs to be evaluated at 1. And so I'll do that with subs and X equals 1. Double equal there. And so we get F of 1 is equal to 3, solve that for C, and let's do a show C and see how we did. And it says C equals 2. And I think that's what we got before, but at any rate, C equals 2. But the problem is it's in these square brackets and so forth. So to get rid of the square brackets, I need to go here and put square brackets of 0 because it's the 0th term. And then that'll be C equals 2. I need just the 2, and so then I tell it I just want the right hand side of what's left, and we should just get a 2 when we evaluate this. And there it is, 2. So now what I'm going to do is, I could call it FP for F particular, but I've already got FP up here and so forth. I could call it P for particular, but I've already got a P there. Maybe an uppercase F is equal to my F plus C. Okay, so now I have 1 over X plus 2. And now I want to plot it. So we'll call this plot a plot of F. And I should just be able to say plot F. Let's just try that. Very simple. And I'll add it then here. Plus F. And we'll see what happens. Oh, not plus F. It's going to give me an error probably down there. So PF. I won't even look. Can't bear it. Okay, let's see. Oh, and it still gave me an error. What's it saying? Wow, got to go way down here. Variable X not found. Good question. So that one stumps me a little bit, but let's try this. Let's just try adding this. I'll do a Control C to copy that, and that to tell it from 0 to 7. We'll see if it gives me the same error. Maybe. X not found. Yeah, this one we may have to stop this video here for a moment because I am stumped, and I'll go looking for a solution so you don't have to look through all that as to why it wasn't happy with this. So for instance, let's just make sure, let's show F. It could be we think we're doing something very different than we're doing. Oh, yeah, it's probably the C. I should have shown that to begin with. So it's what I really should have done, silly me. You say, well, yes, you are so silly. I should have said subs C equal big C. Now let's evaluate. And there we have our 1 over x plus 2. And there's our solution now. That looks really bad, right? Because it did all this. So, yeah, I better, let's go from like 0.5 and evaluate. Still doesn't look good. I'm not sure. Let's see. Let's try. Oh, I changed the wrong thing. 0. So you see, I make mistakes too, and I get stumped too. And you know, I just try to work my way through things. And oh, how beautiful! Okay, and there it is. So we see the slope field and how our solution is kind of connecting the dots. Now, if I were to really connect the dots myself, I probably would have been up here a little higher. I wouldn't have gotten it quite right. But you see, it gives us a pretty good idea. But so here we can draw a slope field using the technology, and after a little bit of trial and error and some mistakes, we can take that derivative, we can do the antiderivative, we can even find a particular solution, we can create that particular solution, and then come down here and plot all these things that we want to plot and show it. And you know, technology is fantastic that way. So, you know, this wandered a little bit more than I would have liked, but hey, we got through it. And again, I think it's important for you to see that, yeah, I get stumped at times, and I play around with it, and sometimes I get stumped for a long time, sometimes just for a short time. This time I just got stumped for short times, and we figured it out. Okay, so a long addendum, I guess, to that, but there I use some technology in the slope fields.